So we would like to hear the next startup insight here on stage, and therefore I am happy to welcome the founder of Nomaze, Finn Geider, to me up the stage. Nomaze helps plant breeding companies develop new varieties that can meet the growing demand in arable farming. Welcome, Finn. Perfect, you're already here. The stage is yours.
Thank you. Hello, everyone. Thank you to the Rentenbank for the invitation. Yes, my name is Finn. I'm the co-founder and CTO of Nomaze, where we're developing the foundational AI platform for plant breeding. And I want to open with a topic that I don't have to convince anybody here. Climate change is already impacting crop yields, not in 10 years, but already today. But zooming in a little bit further, by means of higher frequency of drought events, longer periods of extreme heat, extreme rainfall, and so these really more extreme weather conditions are putting then a lot of pressure on farmers, obviously, to produce still the same returns at the end of the season, and by extension also producing more demand for the plant breeders, as we've already heard, to produce varieties that don't only produce a lot of yield, but also yield stability in these challenging and stressful conditions. And so there's clearly growing demand for products, crop seed products that have these extra traits of stability and low risk. And so we see that as a market pull basically for plant breeding to develop new varieties faster. At the same time, so that's basically a market pull. At the same time, we've heard about it already this morning from Luisa. AI is having a strong acceleration at the moment. There is really a lot going on, mostly outside of agriculture maybe, but technologies are really growing up and becoming more and more capable of handling also the complexity of crop genetics and becoming more and more mainstream. So we see that as a potential for agriculture to really have its AI moment in a way and use those new technologies to at least tackle a few of the challenges that are going on. And so about plant breeding, I mean, this is a number that we see repeated all the time. Basically, it takes 10 years, sometimes even longer, for a new crop to actually reach the market from the first crossing. And certainly can take a lot of money per breeding program to actually reach this successful market entry. Why is it so expensive? There are multiple reasons, but one of the largest driver of costs are certainly field trials. So replicating new varieties across a multitude of different locations, geographies, climate zones, and certainly also years to produce data that new varieties are actually stable and performing well enough under a lot of different environmental conditions. And so what we as Nomaze are focusing on is, one, accelerating those timelines, certainly stepwise, but with a lot of potential down the line to really come to the market faster, but also by reducing the costs of those field trials, by moving more and more of this data generation basically to the computer and directly predicting how a new variety that doesn't maybe yet exist is going to perform under weather conditions that maybe also don't yet exist because climate change is driving us there in the future. And this way to go directly from a new crossing to the variety that is going to make it in the market. This is our goal. And to do that, we've developed a model that we call TraitLens that is based on artificial intelligence. And it's a foundational model that basically looks at the plant's DNA, SNP positions distributed across the whole genome, and can predict certain traits of these plants, such as certainly the yield, but also resistance to droughts and certain stress factors, to diseases, root health, many traits that are interesting for the breeder to optimize for. And we do that by also taking into account the weather and the soil and the management information on the farm that are going to determine the conditions under which the plant is actually being grown at the end of the day. And so, yeah, we haven't only developed this for research, but we've already validated in several commercial breeding programs, with certainly being able to show gains in accuracy, predicting better how plants are going to behave under new conditions, and actually also coming to new results quicker, since turnaround time, of course, is also a large part of this. So these results are from a use case called sparse field testing. Happy to elaborate on that one-on-one if you care later. This is maybe a sneak peek into what our software looks like. We really focus on being, a product, a tool for the breeder to be able to make better decisions. So we don't only focus on the predictions, but also on integrating into the workflows that already exist inside the breeding companies today, and allowing the breeders to make visual selections and data analysis alongside, creating prediction scenarios for their new crops, with the goal of really going towards this predictive breeding mentality and moving more and more of this workflow to the digital in silico sphere, if you want. From a company business model perspective, we started doing a lot of validation projects to actually first check if this technology can even work. And so that's what we focused on mostly last year. Right now, we're really in the phase of scaling up this technology and providing it as a licensable software to breeding companies. But really where we're going with this is to go even deeper, get integrated deeper into the value creation there, and eventually maybe even co-create plants by leveraging expertise and visibility across a lot of different crops and geographies that we now have as a technology and service provider, basically. So certainly really happy to already be working with a number of different companies from mostly the European sphere. We are right now entering the first few agreements with US customers also. They're very secretive, so I'm sorry I cannot put here the logos, but I'm sure you can make a couple of guesses. From our team perspective, something that is maybe noteworthy is that my co-founder Jean-Pascal and I are not coming from the agricultural background. We're really coming more from a technological AI background. So we met at the TUM in Munich, which is actually also where the company is located. Jean-Pascal worked several years at the DLR, working on in-space data centers and applying machine learning there. I come from a health tech background. And so we focus really on leaving the expertise of the plant breeding with the breeder where it belongs, and we focus on delivering the best technology then to them, making it easy to use, right, and bringing it, make the rubber hit the ground. Actually, right now we're raising a seed round, so if you're an investor and you like this topic, then I would be really happy to talk to you after the panel then. We're raising 3 million and we have actually a bit more than 1 million already committed. So yeah, that's going really well. And with that, I will stop talking about Nomaze now, and we can basically talk more about the plant breeding in general in the upcoming panel. So yeah, thanks a lot.
Yeah, thanks for having me. Yeah.